Hi everyone, welcome to CISP 440 Discrete Structures. My name is Alexander Lee and I'm going to be your course TA for the spring 2022 semester. This course is taught by Professor Abida Makaram at Sacramento City College. So in our class, we'll mainly focus on core concepts, and these range from fundamental number theory to graphs and trees. In this class especially this semester, we'll look in depth at how our class concepts translate into industry and affect work in modern computing. So we'll see actually how these concepts that we're learning in class are fleshed out by software engineers. And yeah, now time for some introductions. So our instructor is Professor Makaram. She graduated from Oxford University with a PhD. Her research centered around distributed computing and programming languages. She teaches at Sacramento State University and SCC, Sacramento City College. Here's a bit of a spiel about me. I was mentored by an Intel engineer as part of CCMI, which is the Community College Mentorship Initiative. I'm also going to be an incoming data scientist intern with Intel for the summer. I'm also a participant of the NASA Lucy mission, which aims at community college students across the United States for workforce development. I also work as an engineering student assistant with the California State Department of Water Resources. My course role, of course, I'm the teaching assistant. My office hours will be Saturday and Sunday at 6:30 p.m. or by appointment if those times do not work for you. Today, I'm going to go ahead and just give you an overview of the first large unit of our class. We'll look at binary numbers, and then we'll lead into later videos on integer properties, sets, logic, proofs, and functions. So with binary numbers, this is a very core and fundamental concept to anything revolving in a digital world. So we'll apply this as a foundational cover if you've never seen binary numbers before. Let's take this example here. So we'll have to convert the number 225 to binary. So before I begin, we usually count in base 10, and binary is a base 2 number system. You can see here, I have this array here, array A, and I have these indices. And if you've taken a computer science course before, you know that the first index of an array has a subscript of 0 and so forth. So here you can see that it's 1, 2, 3, 8 elements in this array. So there are 8 bits in a byte. Each of these are a bit, so I want to get you used to that terminology now. A bit and a byte are commonly storage units in a computer's memory. And I will tell you that the max size of a byte, if you want to determine that, you just add up all of these green numbers, and I can tell you now that that will equal 255. So if I have to convert the number 225 to binary, a proper algorithm that I'll ask you to use is divide by 2. Now you're thinking, why would I want to divide by 2 or use this algorithm? Well, let's go back. Well, the way this works is that if I put a 1 here, then I turn on this bit, and then I have a 1 here. So the value will be 1, and I can turn them on or off to create a sum that is equal to 225. Now, you may try and rework this, but it may take you some guesswork and may not be as efficient or as fast. So I want to give you the method that will give you the correct answer in a very short amount of time. That is divide by 2. So what you simply do is take the number, keep dividing it by 2, and take the quotient here. So these numbers here are the quotients. So if I divide 225 by 2, I get a quotient, and we do have remainders. So I turn on that bit here for 1. And I keep repeating this process in a loop until I reach the final bit here. You'll see that it goes 1 0 0 0 0 1 1 1, and we usually order it from the lowest bit to the highest. So we'll reformat here to meet industry convention. I've also fleshed this out here very slowly. So let's look at it very slowly. So we start with the number 225, and then we divide it by 2. Our quotient is 112, and do we have a remainder? Yes, so we implement this check inside the loop. This is the first bit, so its subscript is 0. These are, again, elements in an array, if you will. Then we go back and we have the quotient here, 112, and we divide it by 2 again. The quotient is 56. It divides in evenly. There's no remainder, so we turn that bit off. And this is the second array element, or the first, which is denoted, by a 1 for the subscript, for the index. We then repeat this step until we reach the final final bit here, which is the 8th bit here. So there's 1, 2, 3, 4, 5, 6, 7, 8. I know it starts at 0, so it's a bit confusing, but I just go over it slowly just to make sure this course is accessible, even if you haven't taken a computer science course or a pop computer science course. And again, remember to reformat it, so we flip, so 1, 1, 1 is in the front instead of 1, 0. If you want to look at a binary number game, you can look at this link, which will take you to a game made by Cisco where you can try to put in a number for 29. So you can guess 16, 4, that makes 20, and then 1 and 8, that's 29. So you can play this game. I'll go back to the slides. Or you can do this challenge that I have for you. You'll write a C++ program to convert binary numbers to decimal. And I give these 3 numbers for you as input. So you can go ahead and try that if you want. If you want to read more, I have this link from the Swiss Federal Institute of Technology. It's one of the best universities in the world, ranked just below MIT. So it gives you an entire spiel about binary numbers and binary math. We call that binary arithmetic. You'll see how it's related to ASCII, so we can use strings later on, but we won't go into that for the scope of this course. I just wanted to add that link here so you can see how binary numbers and binary math relate to industry. So this has been a first introduction. You've met me and Professor Makaram, hopefully, and we've looked at binary numbers. Next, we'll look at integer properties, which I will edit out and add in. So thanks, and I look forward to seeing you for the rest of the course. Cheers.